Okay, before we can get into scatter plots and lines of best fit, we first need to learn some vocabulary. So qualitative or categorical data is data based on descriptions. So data based on descriptions. But quantitative is data that's based on numbers. So the way that I remember them is that quantitative, you think of quantity, that's a number, and then the other one obviously has to be descriptions. So bivariate data, this is one that's really kind of confusing, but if you look at the word bi, that means two, so two variables. So let's say that you are going to see if there's a correlation between height and shoe size or height and weight. And then an outlier. Outlier is a value that's far away from the other data. So a value far away from other data. So we're going to look at some trends. So we're going to describe the association between the bivariate data shown in each scatter plot. So remember, bivariate just means that there's two things that are being compared. An association can be strong or weak, positive or negative, and linear or nonlinear. So if I look at graph A is strong. They're pretty grouped together. So it's a strong data. From left to right, is it positive or it's negative? Well, this one is negative because it's going down from left to right. And it's relatively linear. It'd be kind of easy to draw a line through there. Graph B, is that strong or weak? Well, it's weak. Once it's weak, we can't really determine whether it's positive or negative, linear or nonlinear. Weak just means that there's not enough information to determine the rest. Graph C, it's not really strong, but it's not really weak, so it's moderate. I would say it's stronger than it is weak, but it's pretty moderate, and for the most part, it is negative. I would not say that it's necessarily linear or nonlinear. The next one is very strong. From left to right, it goes up, so it's positive. Now we're looking at linear, nonlinear. Well, it curves, so it's non-linear. So we have a family. The table below shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. Draw a scatter plot and describe what relationship exists within the data. So, excuse me, at the age of 3, the annual cost is $10,700. So it's almost to the 11. At age 6, it's $11,700. So it's almost to the 12. At age 9, it's $12,600. So it's a little above middle between 12 and 13. At age 12, it's $15,000. So it jumps up quite a bit at the age of 12. And the age of 15 is $16,700, so almost 17. So we don't have a linear equation. It's not going up at the same amount each time. But we would be able to draw a line of best fit. And the line of best fit is a line that best represents, wow, that is terrible handwriting, best represents a set of quantitative, remember, so that's data, that's numbers, quantitative bivariate, remember bivariate just means two values, data. So let's look at the yields of chemical reaction. There's some data on there, and there's already a line of best fit. So we weren't asked to create a line of best fit. We just already have one for us. So what we need to do is we need to find 2 points on this line of best fit that look like they could be going through a coordinate point. It doesn't have to be perfect, but we're going to do our best. So there's one right here and another one right here. So we need to find our change in y over change in x. So change in y over change in x. Well, it's going down, and it's going down from 18 to 16. So it's going down 2. And it's going over from 75 to 85. So it's going over 10. This reduces down to negative 1/5. This is our m. Now we need to find our b. Our b is where it crosses the y-axis. Well, it crosses the y-axis. It's kind of hard to tell where it really crosses because we have a break for both x and y-axis. So we don't know where it's really crossing the y-axis. So what we're going to do instead is we're going to solve for b. I don't have a lot of room here to write, so I'm going to write it up here on the right-hand side of the graph. So we're solving for b. So remember, y equals mx plus b. We now know our m is negative 1/5. And we can find, we don't know b, but we can find an m or an x and a y. We just pick one of our coordinate points. Well, this coordinate point right here is 85, 16. So our y is 16, our x is 85. So we take 85 times negative 1/5. Well, it's a negative. So 85 times 1 divided by 5 is negative 17 plus b equals 16. We're going to add 17 to both sides. 16 plus 17 is 33. So our b equals 33. Our entire equation is y equals negative 1/5 x plus 33. That is our equation for the line of best fit we were given. So we're going to now use our equation to estimate the yield in grams of a chemical reaction when the temperature is 90 degrees. So if you were to look at the graph, temperature is our x value. So we're going to plug 90 in for x. So y equals negative 1/5 times 90 plus 33. The first thing we need to do is multiply 90 by negative 1/5. So that's the same thing as 90 divided by negative 5. So y equals negative 18 plus 33. And it is 15 grams. We're going to use the equation again for when the yield is 20 grams. Well, grams is our y-axis. So 20 equals negative 1/5 x plus 33. Now we're solving for x. Subtract 33 from each side. So negative 13 equals negative 1/5 x. To get rid of a fraction, you multiply by the reciprocal. A negative times a negative is a positive. And 5 times 13 is 65 degrees.